Good morning to Anja Isham and everyone. We are from Group 3. Today we would like to present our tall building construction project, which topic is heavy lifting. First of all, tall buildings are characterized by their height, which often requires advanced engineering and construction techniques to ensure stability, safety, and functionality. One definition is that if the building aspect ratio height divided by lowest overall lateral dimension is more than 5, then the building is considered as high-rise building. In tall building construction, heavy lifting plays a crucial role, where the need to transport and position heavy materials and components at great height present unique challenges. The process of heavy lifting in tall building construction involve specialized equipment and techniques to ensure efficient and safe operation. There are some examples of heavy lifting machine in tall building construction. First, tower crane is helped in lifting and placing heavy materials and components at great heights. Vertical transportation of material within the building, precise positioning of structural elements, and enhancing safety and efficiency on the construction site. Second, mobile crane is help in lifting and transporting heavy materials and equipment across the construction site, assisting in the installation of prefabricated components and providing flexibility and mobility in lifting operation. Besides, cruiser cranes help in lifting and moving heavy loads in roads or challenging terrains suitable for construction site with limited access or unstable ground condition.
Hi, my name is Wong Lim Seng with matrix number F190224. Now I will present challenges in heavy lifting of tall building. Firstly, weight and size of components. Improper loading due to uneven weight distribution or excessive size. And also, the one-time assembly of massive structure could affect the lifting process. This can be seen on the construction of Sky Park in the Marina Bay. The installation of the steel structure at the top of 3 towers could be the toughest and challenging process. And then reach and capacity limitation. When the building gets higher, the capability for the crane to lift it to the certain level is limited. As the height rises, the load moment also increases. This can be seen in the construction of Burj Khalifa, which be the tallest building in the world. Thirdly, wind loading effects. Wind can cause flexible cable bundling system and impact incorrect landing position and causes building damage. This can be seen in the Burj Arab, which constructed at the seaside when the strong sea breeze wind affect the lifting process. Lastly, stability of tires. Frequent lifting and moving large items can shorten the life and performance of tires. If this situation occur, it can cause reduced control and potential accident to be occur. This can be seen in the Canton Tower construction when the whole structure is surrounded by the steel fragments and the diagonal ring and needed the crane to lift up frequently the steel components and will potential causes the accident to occur. That's all from me. Thank you.
I will explain about the summarize of operation sequence for hydraulic strain jack. If you have ever lifted or dragged a load by pulling on a rope, this will help you comprehend the theory behind how the mechanism works. They employ a similar process of locking, pulling, and unlocking at the top and bottom of the strain jack, similar to what your hands would do on a rope. But instead of utilizing a single rope, there may be anything between the top and bottom of the strain jack. In most cases, the strain jack is installed in a vertical configuration on a support beam directly above the spot where the weight is to be raised. However, this type of jack may also be utilized in a horizontal setting. The activity of raising or lowering the cable is carried out by a massive hydraulic jack, which stretches and retracts when the top and bottom anchor system lock onto each strain and guide it through the hollow cylinder. This process is repeated as the cable is raised or lowered. Next is lifting bridge in Marina Bay Sands by using hydraulic strain jack. After being prefabricated away from the construction site in a total of 14 individual steel pieces, the Sky Park's shell was later placed on top of the towers. Each one was transported by truck to the location Hydraulic strain jacks were used to hoist it into position, and it was put together above the towers. The enormous lifting capacity of strain jack system enables the development of brand new approaches to the construction industry. Two supporting towers, each of which included jacks positioned on an arc at the very top. Jacks are used to elevate the vessel into its ultimate position, which is vertical with the assistance of a tailing crane. There are 16 general step-by-step that we can use as a guide to use hydraulic strain jack. These include load assessment, preparation, connection, hydraulic power pack setup, tensioning, lifting, stabilization and positioning, lowering, disconnection, recovery, safety measure, synchronization, motoring and control, incremental lifting, emergency procedures, and last but not least, post-lifting inspection.
Hi, Assalamualaikum. My name is James Kevin Demonstry, and I'll present Chapter 4 Advantages and Disadvantages Heavy Lifting in Tall Building Constructions. This increased lifting capability of heavy lift equipment in use in both civil and industrial projects to organize larger element projects such as in Gaza, Malaysia and Burj Al Arab constructions. Figure 4.1, 120R tower crane being used to lift pinnacle of GLCC. The pinnacle of GLCC in picture above shows the tallest component consists of a tower piece, measured 65.175 meters, overall length and weight 170 tons. Figure 2, equipment used in the project, labeled LR1750 crawler crane. A crawler crane made by label model LR1750 was utilized during the construction of the Burj Al Arab. Lifting work on arch component weighing 120 tons until 210 tons were completely safe and on schedule, utilizing a 750 tons capacity label. First, tower cranes. At construction sites, large building materials, machineries, and other objects are typically lifted using tower cranes. They are typically placed precisely to carry big loads next to or on structures. It features a wide operating range, a large load capacity, adjustable working height, and more. The advantages of tower crane. Tower crane provide the following advantages, including the loading along with lifting capacities of tower crane are greater than those of every other type of crane in operation. Furthermore, absolutely no other kind of crane can compete with their capacity for height. They can handle the toughest duties and have exceptional stability. Tower crane nevertheless also have significant drawbacks, which are these cranes are quite costly and moving them from one location to another costs money, time and effort. In addition, they require a lot of keep up in form of repairs and derivation. Moreover, they have a labor-intensive installation process. Next is mobile crane. Mobile cranes are often found on transportations. However, those used for constructions are sometimes modified to ride on tractors, and several cranes may be attached to brush for building waterway crossings. The rising arm is often articulated to allow for necessary rising and decrease. Normally, this is accomplished via a hydraulic or cable system. The entire movable structure may be connected to an axis to provide extra stability while it is in operation. Deploying a tower crane may not be viable for many lifting activities. Static tower cranes are unable to do tasks like raising statues or executing lift within building. Mobile crane is thus the most effective answer to this sort of construction challenge. Mobile crane can be set up more quickly. The primary benefit of mobile crane is its adaptability and capacity to enter spaces that a static crane cannot. The mobile crane doesn't take up too much room. The main varieties of crane. The mobile crane is the least expensive, making it more economical choice. The last one is crawler crane. A crawler crane is a particular kind of mobile crane that travels on crawler-style track. So this is where the name crawler originated. They come with telescopic boom or a lattice boom. It does not require setup to travel around the site. The crane can operate without the use of outriggers due to the stability provided by the rings. What follows are the crane's advantages, such as due to its crawlers, the crawler crane is capable of operating on any kind of surface of the ground, even soft surface. Moreover, because of its load is dispersed over a larger area, it may be employed on unprepared sites. Last but not least, a single engine powers a crawler crane, which may have two or more cable-operated drums. Following are crawler crane's disadvantages, such as this equipment moves quite slowly due to the crawler crane's considerable weight. It's difficult to travel from one location to another due to its characteristic. It is not cost-effective.
Hi and Assalamualaikum. My name is Nur Anshafika Hamira binti Hamdan. Today I would like to talk about chapter 5, which is future references, development and demands of heavy lifting machine in the future. For the first subtopic, which is development of heavy lifting over the time, we will take crane as our example. In the past, people in construction have used single pulley concept to construct larger monuments. By applying the single pulley concept, they have managed to create the system that we call it as compound pulley system. This compound pulley system comes with 5:1 advantages, which means every 50-pound force that we apply on it, it will able to lift 250 pounds. However, over the time, cranes are having development due to limited working radius, slow lifting process and difficult to locate the pulley or crane from one to another place. Thus, today, many heavy lifting equipment have been introduced, such as tower crane and crawler crane. The next subtopic is the demands of heavy lifting in the future. According to the research, lifting machinery will have high demand due to its presence in wide range of applications at various industries such as manufacturing, construction, and marine industry. Firstly, it can minimize human workloads and injuries because workers can focus on other jobs. It also helps in reduce risk in worker safety at construction site. And third, broken heavy lifting machine can be repaired or returned by injured workers will bring many problems to the company, since we will have to pay their compensation and our project might be investigated by our safety officer. Secondly, is the capability to lift heavy loads to desirable height. Current heavy lifting equipment can be specifically tailored based on the type of work and task requirements. And lastly, it can increase the productivity, since by having cranes, we can build the taller building according to our tight schedule. That's all. The last subtopic is future references. In the future, engineers will play a prominent role in solving problems during construction of projects. So, as a good engineer, they must be able to learn from the past construction and shift their focus from narrowing on complex technical solutions to large context in solving their problems. As example, we can use the incremental launching method to replace the conventional method in constructing bridge across the water. This is because this ILM method offers advantage in reduced disturbances to surrounding, increase worker safety, and eliminate the need of scaffolding. Even this method is not economical, but it offers a lot of advantages than disadvantages. That's all. Thank you.
In conclusion, the partnership between tall building and heavy lifting machine is characterized by mutual dependence. Tall buildings necessitate the use of heavy lifting machines to overcome the challenges associated with construction at great height. Simultaneously, the demand for tall buildings drive advancement and innovation in heavy lifting machines, leading to improved technologies and capabilities. That's all. Thank you.